think I might, don't know, might be.
All right, we're going to get started. Hi, everybody. We're going to get started. So Priya's going to do the next talk. I'll let her introduce it. But everybody, a round of applause for Priya.
Hey. Hey everyone, can you hear me? Yeah, okay. So I'm Priya. I work for Microsoft Azure and specifically for Microsoft Azure Cloud Shell service. You must have used the shell. I call it like the humble hobbit of all services. Today I'll be talking about something very foundational, which is the migration of distributed systems infrastructure. So you're migrating something in the cloud. I'm not going to be talking about on-prem to cloud. This is about cloud native and how migration is a constant. It's kind of a foundational thing there. And some methodology and insights from that. So, so this is more like an engineering management sort of a question as to why do we need timely migrations, right? So any infrastructure reaches its constraints over time. It could be that the infrastructure, somebody stopped security patching the infrastructure, right? Or somebody changed the way networking works, the networking stack works in the infrastructure. So it requires a timely migration to avoid getting into this vicious cycle of tech debt, where your team is like, it evokes a fear in anyone trying to touch the system, and then it feeds into this, it reinforces the belief that change is futile. Like, okay, I got to rewrite this thing, right? So neglecting or rather procrastinating migration makes your team work on maintaining an existing infrastructure, and sooner you know they're hamster wheeling to stand still, right? So why can it be intimidating? So revamping the backend of a widely used distributed service can be a bit daunting. It's a serious undertaking because your current service that's running right now, it's battle tested, it's developed some robust resiliency practices, it's gone through on-call, it's gone through site reliabilities, and then it's up and running. And trying to revamp that infra into some other infra can be a bit of a intimidating process unless you have like a measured risk methodology, right? Where you say, okay, here's a low risk methodology. I can start cautiously and then I can proceed. So I'm going to talk about the methodology a bit, but then within cloud native, you kind of depend on other services. A service depends on other service. Let's say, some serverless service may depend on storage, for example. These are all services interplaying with each other. And when there are serverless services involved, we all know that debugging is a bit of a challenge. You don't get that much flexibility into debugging something unless that service gives you the monitors to monitor it. You have no idea what's going wrong unless there's an exact monitor for this. So how can you kind of guard yourself against these things, right, when you are using these services and in a migration context? So here's my methodology. I did migrations of infrastructures, and when I started, I was like, where do I start, right? So I thought, like, let me put a methodology as to, this looks like an expedition to me because this is going to be a while because I have to, it's a widely run service, right? So I look at it as an expedition. So you chart the course and then you say like, okay, here's where I start. I will set up an A/B experiment or a traffic redirection experiment first. And then I will identify a path, like how am I going to roll out this thing region by region, right? Because you have cloud in so many regions, and what's my rollout strategy? After figuring that out, the meat of my talk is going to be designing a compass. Basically, what are you going to measure? Because you started migrating your infrastructure, and what are you going to start looking for to make sure that things are going right? what's the first thing we do? We go and check if it's parity, right? There's some service running on your own clusters, and then you're migrating it into a serverless or managed service. You would ensure parity. That's the first thing you would ensure, but what else can we look out for, right? And then how do you reach your destination, which is you complete your migration with no downtime, right? So that's what I'll be talking about. So let's start with charting the course, right? This is like an older infrastructure A, okay, which is your cluster, and then you're gonna migrate to this new infrastructure. I kept it very generic on purpose. If there's any specifics, we could chat about it, but this is mainly to help everyone kind of get a sense of their own infrastructure and put it into their context, right? So let's say this is like your own self-managed clusters, and then you're migrating to a serverless infrastructure. Basically, you used to have your own VMs, and now you started migrating to a infrastructure, which is when you request for a VM or container, it's going to give you, right? So that's the kind of thing that you're going, let's say. And you have a client there, and you can build your own service API B. So this is the one that's in production, right? Serving out of old infrastructure A. And you could build a service API B, and then your client can do an A/B experiment where it can send a portion of your traffic to B. And this is what typically people do. There's a whole lot of front end which does this kind of architecture. But what I like is basically putting the A/B experiment layer over here with many of your tools that are available for feature flagging. When CNCF's got some tools. So you can put the A/B experiment at the service API level so that a portion of your traffic goes to B, to the new infrastructure. This is helpful because in cloud native, it's not necessary that the whole infrastructure is getting upgraded. There are portions of your infrastructure, like say network stack, that's just upgraded. Something's reaching end of life. So it can help you be more granular. And then next, identify a path, right? Now, just figure out a plan for how are you going to roll out this A/B experiment in different regions. I just put a very, generic region, but you could have many factors on how you're going to roll out. But identify a rollout plan, and then let's get into this compass, right? So the first thing that was beneficial to me when I was doing stuff was like, how do I know if this thing is fully working in production? So I've tested my A/B infrastructure in my pre-production, and I rolled it out to production. Now, this is very typical, right? You send all your traffic to your old infrastructure, and then portion of your traffic, you can tune how much it is. Maybe, let's say I started sending 5% of my traffic to the new infrastructure, and it failed, right? Something happened here and failed. The first compass that you could design is you could fall back to A because you got to serve the customer. So you fall back to A, and then you emit a fallback metric. And this is a good compass to have, and it's kind of a basic foundational compass to have, like how many times is your service actually falling back because this thing failed, right? So that's one of the things. Infrastructure health. This is a kind of an interesting topic because let's say your service is requesting a resource, VM, storage, compute, whatever, from a managed service, which is your serverless, and then it's requesting this resource. Is this resource going to be fully healthy till the end of its usage, especially in the context of ephemeral resources, right? Not long-running ones. Like, let's say, even looking at the shell, right? It's an ephemeral resource. So is it going to be healthy till the end of its usage? Which means, is it going to have healthy network connections? And you typically know that in any managed service, you have monitors that will measure CPU, that will measure network connections, that will measure disk. You have all of those physical monitors, is what I call them. They tell you that this is in good shape. whatever I return to you, that's in good shape. But what I would suggest is try to put some logical checks to understand if your resource is healthy. For example, I returned a VM, and it's supposed to derive its DNS settings from the customer's DNS and not your cloud's DNS. Is it going to do that? Is it doing that till when you returned it to the customer? Was that set up properly? So those logical parts constitute health, because what happens is, so here's another example, like, so you have a VM. Is your ingress, egress connections, are they okay? And what are the metrics that will tell that this VM is healthy? Not just from a physical point of view, from your use case point of view. When you're a service engineer or a cloud engineer, like how is it healthy, right? So put this metric in place, and then when there's problems, when you suddenly feel like something's going on that I don't understand, but your managed services monitors is telling that your CPU is healthy, your disk is healthy, so what's going on? This kind of a metric is going to help you understand those kinds of use cases when you migrate, right? Because you got to always watch if things are going right. So in such a case, when you zoom out, I'm going to give a real example. When you zoom out, you will understand who is healthy and who's not healthy, more than alerts, right? So this is an example where a resource, a VM, was supposed to be fully connected, like constantly having connectivity for about 6 hours from the time it was returned to the customer. So the customer requested a VM, you returned it as a cloud, and then for 6 hours it's supposed to be healthy. But then it wasn't. It's intermittently healthy, you know what I mean? So here, if you look at this is a graph that shows the network disconnects and a resource not being healthy. And when you zoom out and put these kind of scatter charts, that's very helpful to identify the picture, right? And typically when you're having managed services, they are running it in big computes with multiple tenants and stuff like that. So if one of the resources takes too much of the underlying compute resources, for example, in a node, one of the pod takes too much of bandwidth or is starving the other pods, you have a noisy neighbor issue, right? And it could be, this is fascinating because it could manifest in any way. So zooming out helps. And here's an example is once you go fix it, once you talk to the service and then you raise incidents or whatever and you fix it and you get them to fix it and you can see the difference, right? All of them are having a healthy lifetime. Like they all are healthy up to the 6 hours that you wanted them to be healthy, or 4 hours or whatever. So zooming out in a compass is super helpful. So a noisy neighbor by itself is very interesting. So if I want to just share, so one of Azure's Azure public documentation has a noisy neighbor pattern, which is there. If you click on the link, it'll take you there, where it'll explain what are the different scenarios. People do upgrades all the time. So if your managed service upgraded its OS or kernel, and that changed something like something at the network level, you could see disconnect. So these are things that you might want to think, okay, is my service actually seeing these issues, right? So yeah, and these things are very hard to debug, and it can really eat up your time. So it's good to have a compass. And it's nice to keep local health probes rather than go to the cloud and use its control plane to kind of ask for health of a VM, right? Have your own local health probe. This is a debatable topic from a design point of view. Some would say, I want everything to go via my control plane. That way I have good visibility, security. There's also, from an SRE point of view, You could look at the local health probes and see if it actually came up. You could set up your local metrics with your favorite monitoring tool. And when you have a service-to-service interaction, please keep in mind the service limits and, of course, rate limiting, exponential backoff is all implemented by most services, but any of your services bombarding another service with a lot of requests as scale increases needs a bit of a rethink. So it's best to kind of honor service limits. And as part of the service limits, factor in retries. So retry is a big topic where you can either kickstart a retry storm and totally eat up your service limits, or you could look at how many times you're retrying. Is the retry logic pretty solid in my service? There's also an Azure documentation on anti-pattern documentation, which talks about retry storms. It's public documentation, and I can put a link to that. And of course, there's many verbs, right? There's get a VM and put a VM, or so each of those verbs have service limits. So every single thing in part of your entire infrastructure has scale limits. So let's say you're requesting 200 VMs. They all need to have IPs, and there are scale limits to these things. IPs have scale limits. If you have a virtual network, that's public in Azure. You have public documentation that says, here's your limits for your IP addresses. So sometimes the way a managed service may handle is it may just be continuously retrying to get an IP address, or it may not have good indicators that I can't find an IP address, let me just continuously retry, and you would have no idea about it. So try and have these scale limits in mind and ensure that each of these, small aspects of your infrastructure, I won't say small, it's something that's easy to overlook, and so just remember that every small thing has scale limits. And then let's say you put a graph of all of these things that I discussed. You can start tuning it, and you can look at the fallback metric. Okay, I sent 5% of my traffic, and I saw 10 of them fall back. So, or a significant percentage of them fall back. Go back, debug it, and then fix it put some right compasses to measure that going forward, and then make sure your fallback is continuously coming down, right? Increase the traffic percentage, measure your fallback. So how does your service fare with the new infrastructure? That's what this is telling you. And now it's just a bunch of knobs, and then you're tuning your migration. So when do you call your migration complete? So you can say the fallbacks are 0 over a period of time. All traffic is accounted for in that region. This is kind of interesting because I've listened to quite some people say, okay, this traffic is not important, or a specific percentage of the traffic is just test traffic. So make sure your entire production traffic is accounted. And of course, parity, that's the first thing people focus on. And then you can just rinse, repeat this whole process for the other regions. So using an A/B experiment armed with a dashboard that acts as a compass, being mindful of these things that I said, and configurable parameters that could be tuned, you can just do a successful migration and call it complete, even for the most granular things that you're going to migrate. So there are parts of this talk that are specific to certain resources, and each person's cloud or whatever they're migrating could be very different. But I think the framework could generally be helpful. And with that, Thanks for listening to this presentation. I'll be very curious to hear if you have any migration stories that you want to share. Please feel free to chat with me and reach out to me. And I'm open for questions, yeah.
Do we have any questions?
Do we have any questions? Going once? Going twice? All right, thank you so much.
Thank you.